I'm Amberly, and welcome back. By now, you probably know how I feel about building good habits, and you've probably also heard me say that I think it is so important to have a plan for your programs before you begin to code. By doing some of the work up front, you save yourself a lot of time, energy, and frustration. In our last video, we completed 2 planning steps for our buffet point of sale program. As a reminder, the program's function is to show the user their total bill with an itemized receipt, and that includes the buffet cost for their whole party, tax, and tip. In this video, we're going to reap the benefits of our previous planning process and code out our program using the plan that we put together. If you didn't see the previous video, don't sweat it. I'm going to kick us off with a quick refresher. If you're planning to follow along with me, pause the video now and resume when you're set up. I'll see you soon. So just to review before we get started, this is an example of the receipt that we're going to recreate for the user. Now, as you can see, that means that we're going to need to show them the total bill, which is composed of the cost of the buffet, plus the tax, plus the tip. With our deliverables in mind, we started planning out our program by first putting together all the formulas that we need to do those calculations. Using the box method, we reverse engineered the user's total bill, and that ended up showing us 4 different formulas that we're going to need in our program. This completed model also gave us a list of all the variables that we'll need, and it turns out that in order to make our calculations, we're going to need to get some information from the user first. So num diners and tip rate are going to have to be initialized using cn. Next, we made our flowchart. Knowing that we couldn't do our calculations until we had everything we needed from the user meant that we would need to initialize tip rate and num diners first things first in our program. After that, we could do our calculations, and then finally, we'll display the receipt to the user. When we did a dry run of our program using the flowchart, we even generated a set of test data so that when we run this for real, we know what we expect to see. So, just to recap, this is all the work that we did in the last video. We're going to start coding here in a second, and because of our planning, we already know all the variables that we're going to need, steps we have to take, what order we're going to take them in, and how we're going to do our calculations. Are you ready to roll your sleeves up? Let's do it. Okay, here we are in Visual Studio. I've declared all of our variables that we identified and initialized our constants. I've also included the IO manip library right here. We're going to use this for set precision and set width, which will make our output look really nice and professional. If you ever want to declare variables of the same type in one declaration, you just need to separate it with a comma. This list form is really nice for readability and obviously for commenting. I use the tab key to push these over and keep them all lined up really nicely. Even though this declaration is not on the same line, the compiler is going to continue through these and separate them by the comma until it gets to the semicolon, since that's what marks the end of our statements. If you're planning to follow along in this video, go ahead and pause now and type this up with us real quick. Now we were able to come right in and declare all these variables right off the bat because of the planning that we did earlier. And another part of that planning was putting together our formulas, right? So let's go ahead and add those too. If we wanted to, we could go through and add comments to each of these, but since the variables themselves are commented, we can kind of go in and backtrack and see how these formulas are all being built, right? But now, in the spirit of modular programming, before we continue, let's go ahead and run this just to make sure that everything's working as we have it so far. And we're getting an error. Let's take a look here and see what we've got. Okay, so this is telling us that we have an uninitialized variable num diners on line 21 and uninitialized variable tip rate on line 22. What does that mean for us? Well, if we think about what initialized means, which is when we give a variable a value, this message is telling us that an uninitialized variable is being used on these lines. So if we take a look here, the compiler is totally right. So it's basically telling us like, hey dummy, you're trying to use a variable in this calculation that has no value. How am I supposed to do anything with it? Well, some of you who remember from our previous video, we actually ran into this same problem when we were doing our planning. We got stuck on calculating out the tip amount because we needed to know the tip rate first, right? So this is just the digital version of that analog problem that we've already solved. So the way that we handle these types of errors, these uninitialized variables, is to, you guess it, initialize the variable. Now in our case, because we already solved this problem, if we look at our flowchart, we know that we need to initialize these using cin and get that information from the user. Now we can also see in our flowchart that this collection step has to happen before our calculations, which in our program is going to be right here. So I'm going to give it some space. And of course we can't just do the cin, right? We need to tell the user what we want. We need a prompt, so that'll include a cout. So I'm just going to pop this right here. We have another cin for the tip rate, so let's go ahead and collect that too. Just pop that right there. And I put a new line character here so that this just pushes down one line for readability. And that is 100% just for the user. Everyone, hear me. When I say that it is important to consider the user, I really mean that. You know, as a developer, they're basically our customer, right? So without users, there'd be no program, there'd be no job for us, and that would be entirely detrimental to my sushi addiction. So I'm very highly motivated to make everything very user-friendly, and we're going to be working on that a little bit later in this as well. All right, so we have both our cins done, and according to our flowchart, our next step would be our calculations. We already have those right here. Awesome, love that. So the very last thing to do is to display all this information to the user. So I'm going to put that right here after the calculations, just like our flowchart. And of course, again, consideration to the user, I've got these new line characters here to have each of these statements appear on a new line, and that'll be nice and readable. All right, so that was our last step. Let's run this baby. We're going to hit our local Windows debugger, and here we go. All right, so there's 5 people in my party. And it's an X server doing 20%. And yikes, those numbers are not right at all. Or are they? How do we know? Well, let's check it against our test data from the last video. So according to that, what we should be seeing here is a meal cost of $64.75. Okay, that's right, perfect. Tax, $4.85. Okay, you know, kind of maybe too much here, but right numerically. Our tip, dang, our tip amount here should be $12.95, but we're currently looking at $1,295. And then our final bill with that extraordinary tip is $1364.61, and we should have $82.55. So these numbers are not even close, really, some of them, to our test data. What happened? We didn't get any errors before we ran this, so what's the issue? Well, ladies and gentlemen and non-binaries, we have encountered our very first logical error. And a logical error means that we coded everything correctly, but we've just forgotten some sort of step in the process. Logical errors are by far the most difficult to deal with for this exact reason. There's really no sort of warning, just funky behavior. So let's take a look here and see if we can find the problem. Now, my personal favorite tool for addressing logical errors is a Visual Studio feature called the step-through. The step-through allows us to run our program line by line so that we can see it executing one step at a time. When we run it using the debugger, it just all kind of happens so fast, we don't really have the chance to slow it down and kind of see where any funkiness might be going on. So there's 2 ways to trigger this feature. First, you could press F10 on your keyboard, or if you would prefer, we can look for a little symbol in our menu bar up here, which I do not have, so we're going to go ahead and add it by going to View, and then we're going to find here Toolbars. Okay, excellent. And Debug. So this shows us now the debugging toolbar, which should have appeared somewhere up here for you. We're going to look for this little arrow right here. Okay, when you find it and you're ready, let's go ahead and click. If you're not using Visual Studio, chances are that whatever IDE you're using has something similar, so I recommend taking a minute to Google it because this is seriously such a super handy feature. Okay, so as you can see, our views kind of shifted a little bit here. We saw our console window pop up, but nothing's there yet. That's okay. And then we've got some information here. The window that you want to make sure you can find is this Autos window here, okay? If you don't see the Autos window, it's very easy to add. We're just going to come up here and go to Debug, Windows,
and then there it is, autos. Just go ahead and click on that. Also, just an FYI that this autos window will only appear when you're in this particular debug mode, the stepping through mode. We wouldn't see it outside of that. So how this window is going to help us is, now that we're in this kind of step through mode, we can, like I said, move line by line through our program. Over here, this yellow arrow is telling us where we are right now. To step through, you can press F10 on your keyboard, or you can press our step key here. So as we press it each time, we can see that our arrow moved, and that's taking us down line by line. So right now we're hanging out here on line 9, and if we look in our autos window, we can see that meal price is here, but it kind of has this like garbage value in it. That's okay. That's because we're on this line, but we haven't executed it yet. So if we step down one more line, all right, we're on line 10, which means that line 9 has executed. So we can see here that meal price now kind of has the the computer version of $12.95, right? The repeating nines, close enough. And so this is why I love the auto window, is because right here we can see the variables getting their values without having to print them to the console, and we can kind of do it slowly. So let's keep going and stepping through. All right, so I pressed that once more, and it appeared to kind of skip this part because there's not really much happening there. This is our next like actionable statement. And so here we are on line 20. All right, and let's just keep going, keep stepping. Okay, excellent. And so now we have hit num diners. And as I tried to step past that line, now here my console is prompting me. So that's why we didn't see anything before, it's just because there wasn't really anything to see. So now it wants to collect for me, so I'm going to say 5. I'm going to press enter, and we kind of resume here now back in our workspace, and I can see that num diners was successfully initialized to 5. Okay, let's keep on stepping. All right, now we're going to collect our tip rate, which again, I'm committed to the good old 20. Okay, and so now we're coming down here, and we can see there's meal price with our value, and then num diners with our 5, perfect. Food cost still has garbage because we're on that line and we haven't executed it yet. So let's step down one more. All right, so now food cost has our value of $64.75, which is correct. And if we want to see the details on that, we can go up here and hover above num diners is 5 times basically $12.95, and that does give us $64.75. So perfect, okay, next please. Now our tip amount, oh, dang. Okay. Now, here's where we started seeing some funkiness, right? I am a super generous person, and I sympathize with the server of the struggle, or the struggle of the server, because I did it many years. But in all those years, I'm telling you that this is not a real tip number. So let's look into this a little bit more. So our tip amount is equal to our tip rate, which is the 20 that I typed in, right? And that's right. I typed it in, times food cost, which we just decided was correct. And if we take this amount of food cost, $64.75, and we times it by 20 in a calculator, it does give us $12.95. So our formula is actually working as we programmed it. Is anyone seeing the issue here yet? Yep, we knew it and we missed it. Dang it. Computers don't do percentages, they do decimals. So we need our tip rate here to be in a decimal. Now, we could try to change this prompt up here to say, like, please enter the amount that you'd like to tip in a decimal, but that would be a really terrible user experience. And again, that is not what we're here to do. So we want to take as much work off the user's plate as possible. So what we should do then is on the back end is to take this percent and convert it to a decimal, right? Now that we've found our issue, let's stop our step through debugging mode, and I'm going to do that by clicking this stop debugging button right up here, or you can press Shift F5. And let's go ahead and address this little troublemaker. Okay, so how do we go about changing this from 20 as a percentage into the decimal that we need? I'm not going to lie, when I came back to college, it had been like a decade since I had done math, and I had to call my dad and ask him. He thought he was off the hook with homework help, but no. But now that he's told me, I can confidently tell you that to convert tip rate to a decimal, we need to take whatever the user types in and divide it by 100. Nice and easy. Now, you might think that we could just put that like right here as part of the CN statement. They type it in. CN is a tip rate divided by 100, but As you can see, that's not going to work for us, so it needs to be its own statement. Now, even though this is kind of like a formula, because we're doing math, we don't need another variable. In fact, we can just update the value of tip rate. And what I'm about to show you guys totally blew my mind as a student, so brace yourself. Here we go. Boom. Now, the reason that I was getting hung up with this as a student is because I felt that it was a lot like defining a word in the dictionary using the word, right? I mean, how can I take the value of tip rate and divide it by 100? Wouldn't that just be like some sort of continuous calculation loop where this just, always gets smaller and smaller? In fact, not. So because of the difference between humans and computers and how we do math, remember that computers do an operation direction, assignment operation from right to left. So this is going to happen first. It will take the value of tip rate divided by 100 and then take that and assign it into tip rate. Okay, so in English, this reads as tip rate is equal to the current value of tip rate divided by 100. And because of the assignment direction, with this happening first and then going into here, it will keep that updated value of the point whatever moving forward. So let's run our program one more time and see if this fixed our issue. All right, so we're going to use our local Windows debugger. Here we go. And again, I've got those 5 people in my party. We're going to keep using our standard test data. 20%. Okay, and much better. Okay, there we go. $12.95, much better. And of course, now our final bill is looking good too. So excellent, everybody. We have the gist of this done. You might call it done, but we could make this so much better, right? This is kind of, not presented very well. Doesn't really look a lot like the receipt. So since we're working with money, let's make this so that all of our values only print out to the 2 decimal places. To do this, we are going to use our setPrecision function. And that was part of our IOmanip library. So remember that setPrecision allows us to decide how many digits are going to be displayed in a value, either the whole digit, the whole value itself, or the decimal point. For us, we just want to work with the decimal, so we are going to be using the fixed version of setPrecision. And we want that to come out to 2 decimal places, so we put 2 there as our function argument. And again, because this is going to apply to every cout statement that runs after it, it will automatically set the precision for all of these to 2. If we had not put this fixed here, all of these values would only be able to print out to 2 decimals. So like our tip rate or our tip amount there would just be 12 instead of $12.95. But by putting fixed, it's going to make us go 2 decimals out for each of these values. Let's run this again and see how it looks. $5.20. Hey! Oh, that's much better, okay? Right? That looks very much more like monetary values, right? Coming out to the 2 decimals, but we could still probably polish this up just a little bit. So this is what our output looks like right now. We did a great job of displaying our values in a monetary format with the 2 decimal points, but if we take a look at the original receipt, we see that our output could really benefit from some alignment. Notice on the receipt how all the decimals of those dollar values are all lined up nicely? By aligning the dollar amounts to the right and the text to the left, that space in the middle has now created 2 very nice columns, which makes everything much easier to read. If we did that in our program, it would look like this. Isn't that so much better? Okay, so how are we going to do this? Well, I've written out what we want our final display to look like. All of our decimals lined up here. Now, one approach I've seen is to manually print out these spaces as part of our cout command. So for meal, right here, I would need to add about 10, 9, 10-ish spaces, right, to our cout statement before calling our food cost variable. But one of the biggest principles as a programmer that you have to remember is building for scalability.
that means creating a solution that's going to be able to handle pretty much anything that the user could throw at it. So that means you have to think about all of the different ways that a user might use your program. Now, my dad, he's one of 12. Our family reunions are seriously huge. There's so many of us that we actually dress and color code by family so that we know who's with who. If we went to this buffet, you bet the bill is going to be more than $64.75. So conservatively, let's say that this bumped up to $164.75. If we coded our spaces out to here manually, that means that to print this extra value is going to shift our entire output by 1 out to here. That's going to break our decimal alignment, so this idea is not going to work for us. Once again, we see that hard coding is the total opposite of scalability. Now, ideally, we would be able to create 2 distinct columns here. So, just like this in our output. And let's say that everything on this side was aligned left, and that everything on this side was aligned right. So that way, pretty much whatever prints out on either side is going to keep its alignment and stay correctly positioned. Now, luckily, we do have a C++ function that can help us do that. Okay, this is called setw, and we know it's a function because of these parentheses right here, right? Setw is part of the IO_manip library because it's going to allow us to manipulate the width in characters of a cout statement. And we can give it either a left or a right alignment if we want to. So let's start with our left column. We want to align this to the left. So in my setw function, I'm going to write our alignment right here as left. Next, we need to populate this argument right here, and this is going to be the number in characters that we want to make the width of this column. So to figure out that number, I like to start by counting the characters in whatever is going to be the longest output of that column. So for us, that's final bill, right? Here's how I do it. Nine, 10, 11. All right. So I like to make these little humps like this here. And this is going to tell us that we have 11 characters. And yes, we do count the spaces and also this colon right here, because even though it isn't technically part of like the word, it's still part of the output. And computers, they don't know any different. They're dumb. They only know what we tell them. So the way that setw works is it's going to take the width that we specify and subtract the characters in that cout statement, and then insert any remaining spaces to make up the difference in an effort to either push that value to the left or to the right. If we made this column a width of 11, we wouldn't really be taking advantage of the setw function, because the width of 11 and our width of final bill, it wouldn't leave us any spaces for that difference to try and push it. So I usually like to pad my column with a couple extra spaces just to give us a little literal wiggle room. So let's go ahead and make this 15 characters. And that's going to buy us a couple extra over here. So these extra spaces here are going to be inserted, and they are going to push this over to the left, like this. And this is going to have a width of 15. So now what about this column? Well, we know it's going to be right aligned. So that means any extra spaces that we have are going to be inserted here on the left in an effort to push that to the right. So what should we make the width? Well, we know that we are going to need at least 3 for our decimal values, right? Because we have 1, 2, and then 3. And how many digits could we expect to see on the other side of our decimal? Well, like I said earlier, with my family, 3 digits is not unrealistic. But what about 4? Could we expect to see 4 on the other side of the decimal? Well, spending 4 digits at a buffet is probably unlikely. But for a corporate event or something, within the realm of possibility. What about 5? That's probably never going to happen, right? So let's just stop at 4. That's going to give us a width of 7. Okay. But let's make it 10, just so that we can buy ourselves that little extra padding. Okay, and those extra spaces will be inserted here on the left in an effort to push that to the right. So just to recap, we're going to create 2 columns using set width. The first is going to be for our literal text. It's going to have a width of 15 characters, and it's going to be aligned to the left by inserting any extra characters on the right. Our second column is going to be a width of 10 characters, and it's going to be aligned to the right because any extra characters being printed are going to be inserted on the left. So I think this is all going to work great. You feel good? If you need to rewind before going back to the keyboard, do it. I'll see you on the flip side of the screen.
And we're back. So here we are at our cout statements. All we need to do now is implement our columns. So let's orient ourselves just real quick. The way we have it set up now, we have both our left column, which is this literal text here, and our right column in the same cout statement. We don't need to separate these statements to put them into our columns. We just need to place our set width function in the proper area within this statement. Now, to be able to figure out the right placement, there's something that you have to understand about set width. Unlike set precision, which is going to apply to every cout statement, multiples of them, that happens after it, set width is only going to apply to what comes after it within that one statement. So while cout kind of works on more of like a larger level where it is encompassing everything after it, set width is going to work on more of a local level and just within the statement that it's placed on. So if I were to go over here in front of meal and say set width 15, my left alignment, everything from there on out would be part of that set width. So we would only have 15 characters for both our literal text string of meal and our food cost variable call, and then it would try to push them both to the left. Obviously, that's not what we want. But we do want it to apply to meal, right? We want that to be pushed to the left, and we decided that that column is 15 characters. So what we need to do is we kind of just need to make a column break here within part of this statement, kind of like that would happen right here, right? So all we need to do then is add a second set width, and it's going to apply to everything after it, which is food cost. So for our right column, okay, so this is going to execute set width left, that'll apply to meal, and then it's going to hit this command, set width, and that's our right column, and that will only apply to food cost. When we get to the semicolon right here, our set width dies off because it's only going to apply to that one statement. So before we add our set width to our last cout statements, let's go ahead and run this and just make sure it looks like the way we think we want it to look. Oh yeah, very nice. Look at that. Okay, so we'll just update these and that's going to look real sharp. Now, I'm going to come over here and I'm going to cheat so you guys don't have to watch me type it. Okay, very nice. So we just repeated the same thing, set width 15 left for all of our literal text right here, and the set width of 10 aligned right for all of our variable calls to get our columns. Let's run this and check out our handiwork. Oh yeah. Oh, that looks so much better, right? Guys, it is totally worth going the extra mile to make things look professional. Your boss is going to be pleased, the user is going to be pleased, and you can take a lot of pride in it yourself. Bravo.
That's all I've got for you today, everyone. Great work. We did some really cool things in this video, and we seriously rocked some professionalism by implementing our plan, considering the user, and we made it all look good to boot. And I know, based on my experience, that someone watching this is going, but Amberly, what about the dollar signs? Well, I'm gonna be real with you. They can be tricky to place properly, and it would have cramped our learning experience to get into that. But that being said, I leave you with a challenge. With your newly crafted knowledge from this video, you have everything that you need to go figure that out. Seriously, go give it a shot. I know you can do it. Before you go crush that though, remember, your ideas have more value than a variable and they're worth calling. Bring that baby up. I'll see you next time.